Hello, so this will be the second part of our discussion in graphing rational function, and this will be the second example. We have to sketch the graph of f of x equals x all over x squared minus x minus 6 and state the domain and range. So we have to first find and plot the y-intercept if there is by evaluating f of 0. Doing that, we have f of x equals x all over x squared minus x minus 6. Replacing x by 0, we have f of 0 equals 0 all over or divided by 0 squared minus 0 minus 6. Or it will be 0 divided by 6. It will be 0. Okay, so if x is 0, then y is 0. So the x or the y-intercept is at the origin, 0, 0. Okay, this will be the graph of, or the, if we plot the x or the y-intercept will be on the origin. So we have there the red dot to symbolize or to graph the origin. For our step number 2, we have to find and plot the x-intercept if there is. Okay, by equating the numerator to 0. Since the numerator is x, we equate it to 0, so we have x equals 0, and that will be the value of x when the y is 0. Okay, so the x-intercept and the y-intercept are just the same. It is both on the origin. Okay, plotting this x-intercept, we have this. So for our step number 3, we have to equate the denominator to 0 and solve for x. Then sketch the resulting equation using dashed line. So we are going to equate the denominator to 0, which is x squared minus x minus 6 equals 0. And by factoring, we have x minus 3 and x plus 2 as the factors of this quadratic trinomial. And by the zero product property, x equals 3 and x will be equal to negative 2. So these are the vertical asymptotes of the graph. Okay, so we were able to solve the vertical asymptote of the graph. Okay, so drawing or sketching the vertical asymptotes. Okay, the red line represents the vertical asymptote. Take note that it should be broken line, drawn by a broken line, because those are vertical asymptote. Those are not included in the graph. Okay. For our step number 4, we have to find and sketch the other asymptote using dashed line. So we have here, since the degree of the numerator n, which is equal to 1, is less than the degree of the denominator m, which is equal to 2. Therefore, the horizontal asymptote is the x-axis. For those who will ask me, sir, why did you arrive at that conclusion? Okay, we already discussed this on the first part of the video. Okay, if the degree of the denominator is less than the degree, or the degree of the numerator is less than the degree of the denominator, we have this conclusion. So plotting or sketching the horizontal asymptote, we have their broken line on the x-axis. Okay, it tells us that the x-axis is a horizontal asymptote. So we have here the table of sign, and the intervals are obtained from by dividing the number line by the zeros and the vertical asymptote of the graph. We all know that based on the previous slides, the vertical asymptotes are -2, x equals -2, and x equals 3. And the x-intercept is 0, 0. So those points will be the one we'll be using to divide the number lines. So we arrive at these intervals from -infinity to -2 exclusive, because -2 is the vertical asymptote, x equals -2 is the vertical asymptote. We are not including -2 in the graph, okay, or in the solution. And second interval is from -2 to 0. 0 is inclusive because the graph will pass through the x-intercept. Okay, this 0 is obtained from the x-intercept or the y-intercept. That is why this one is included. Next one is from 0 inclusive up to 3. Take note that 3 is also not included because we obtained that from the vertical asymptote. And the last interval is from 3 exclusive up to positive infinity. So we have these test points, -3, -1, 1, and 4. These numbers fall between those intervals. So let us have this -3. By the way, x here is obtained from the numerator, and x plus 2 and x minus 3 are from the denominator. So we have your -3. We replace x by -3. So we have your negative. Okay, it should be negative. -1 times, or negative, replace x by -1. So we have negative. Yes, this should be positive, because replacing x by 1 and replacing x by 4. So let us see if our answer is correct. Negative, negative, positive, positive. So our answer is correct. For the second one, we have -3 plus 2. We have here -3 plus 2 should be negative. -1 plus 2 should be positive. 1 plus 2, it should be positive. 4 plus 2, it should be positive. And let us see if our answer is correct. Okay, so it is correct. So how about for the third one? So we have x minus 3, -3 minus 3, -6, it should be negative. -1 minus 3, -4, still negative. 1 minus 3, -2, negative. And 4 minus 3, we have here positive. And let us check. Okay, so our answer is correct. Now, multiply the signs. We have negative times negative, positive. So we have here positive. But multiplying positive to negative will give us, yes, this should be negative. Negative times positive, we have here negative. Okay, but negative multiplied to negative gives, or this should be positive. Okay, that should be positive. So we have your positive times positive. We have your positive, and then positive multiplied by negative should be negative. And because these are all positive, this will be positive. So let us check if our answer is correct. So our answer is correct. Negative, positive, negative, positive. So these will be the sign of the function for each interval. Meaning to say, for the first interval, it is located below. Okay, it is located below the x-axis. For the second interval, it is located above the x-axis. For our third, it is located above or below the x-axis, and for the fourth interval, since it is positive, it is located above the x-axis. Now we are going to use a smooth curve to complete the graph between and beyond vertical asymptotes, excluding any points where f is not defined. Okay, this will be the graph. As you can see, here we have the graph approaches to the horizontal asymptote. It is located below. Okay, based on the sign table, and the graph also approaches the vertical asymptote x equals -2. Now for the second interval, it is located above. So we have here the graph approaches to the vertical asymptote, and since we have here the x-intercept, it passed through the origin. It is the x and the y-intercept at the same time. So as it passed through the origin, we will go to the third interval, which tells us that we must draw the third interval below the x-axis. So after passing through the origin, it goes here. When it approaches the vertical asymptote x equals 3. Okay? And as you can see, because of the sign table, it tells us that the sign of this third interval is negative. Therefore, it is located below. And for the fourth one, we have here, okay, it is located above because of the sign positive. And since x equals 3 is a vertical asymptote, the graph approaches to x equals 3. Same goes with this one. Since y equals 0 is a horizontal asymptote, the graph approaches to the horizontal asymptote. Okay? Now, since we have here the horizontal or the vertical asymptote as negative x equals -2 and x equals 3, we exclude that or those values in our domain. So the domain will be a set of all real numbers such that x is not equal to -2 and 3. For our range, okay, you may think that we must exclude the value for y equals 0 because the horizontal asymptote should be excluded in that range. But since, as you can see on the graph, it passes through the 0, 0, okay, we will include 0, 0 in the solution. In other words, all real numbers are the range of, or will be our range. The set of all real numbers is the range of this function. So that will be all for the second part of the video in graphing rational function. If you like this video, you may press the like button and hit the notification bell and subscribe to my channel if you're not yet subscribed, so that you will be updated to our next videos.